The theory of relativity, Albert Einstein. In early 1900s, Albert Einstein came up with a special theory that completely changed the understanding of space and time for all the physicists. Before this, space and time were considered as fixed as claimed by Sir Isaac Newton. But Einstein put forward the best theory of century to prove that space and time were not fixed but like a fluid instead. This theory is mostly explained in two concepts. 1. The theory of special relativity. 2. The theory of general relativity. Let's learn the special relativity first. Special relativity explains how speed, mass, time, and space are all interrelated. The theory also introduced the famous formula E equals mc2, which stated that energy is equal to the mass times the speed of light squared. The first postulate was that the laws of physics are the same everywhere, regardless of the frame of reference, as long as the frame was not accelerating. This meant that physics operates the same whether you are on an orbiting moon, floating alone in outer space, standing on planet Earth, or flying in an airplane. The second postulate was that the speed of light was constant regardless of the motion of the light source or of the observer. This means that, however counterintuitive, if a parked car and a moving car both turned on their headlights simultaneously, the two streams of light would nevertheless move at the same speed. Essentially, it's a theory of gravity. The basic idea is that instead of being an invisible force that attracts objects to one another, gravity is a curving or warping of space. The more massive an object, the more it warps the space around it. For example, the sun is massive enough to warp space across our solar system, a bit like the way a heavy ball resting on a rubber sheet warps the sheet. As a result, Earth and the other planets move in curved paths, orbits, around it. This warping also affects measurements of time. We tend to think of time as ticking away at a steady rate. But just as gravity can stretch or warp space, it can also dilate time. If your friend climbs to the top of a mountain, you'll see his clock ticking faster compared to yours. Another friend, at the bottom of a valley, will have a slower ticking clock, because of the difference in the strength of gravity at each place. Subsequent experiments prove that this indeed happens. This is how we got the best theory of modern-day physics that helped us to understand so many important concepts in daily life physics as well as space and time. You will always be remembered, Sir Einstein.